We are diving into the final section of our grade 11 Euclidean Geometry section, and we are doing this section now called Cyclic Quadrilaterals. Okay, so quad, that means four, a quadrilateral, a four-sided shape, and now they are cyclic because most of our geometry at grade 11 level involves circle. Okay, so before we dive into the theorems, let's just quickly have a look at what exactly makes a cyclic quadrilateral. Over here we've got figure A, B, C, D, and what you should notice is that each of these points, A, B, C, and D, lies on the circumference, okay? And so a cyclic quadrilateral is a quadrilateral with all 4 points, let's call it vertices, the corners of the shape, on the circumference of a circle. Okay, so the minute that you see a shape, if they tell you here's a circle, they'll usually say something like A, B, C, and D are points on the circle or points on the circumference. Then you can decide that is a cyclic quadrilateral. Okay, if you can see it, you may assume it in that sense. Okay, so if all 4 points are concyclic, that's the word we use, then you're dealing with a cyclic quadrilateral. And that is important because there are a number of theorems that we need to know. Okay, so the first one says that the opposite angles of a cyclic quadrilateral are supplementary. So if we hadn't seen this sketch at all, we would say 1, 2, 3, 4 corners of a four-sided shape all on the circumference means this is a cyclic quadrilateral. And so this angle plus this angle will be supplementary. Now supplementary means add up to 180 degrees. Okay, so if I wanted to know how big is angle B, then I could say, okay, well, B plus D must equal 180. Reason, opposite angles of a cyclic quad, and therefore B plus 86 equals 180. So B is equal to, if we take that over, 94 degrees. Okay. Alternatively, I'm sure you knew it was coming by now, if they gave us these two, but we didn't know, sometimes they don't actually draw in the circle, but they'll give us angles like this. Okay, so let's say we are given the fact, let's actually do this in another color. Let's say we are given the fact that we know that 94 plus 86 is 180. But given the fact that angle B is equal to 94 and angle D is equal to 86, therefore B plus D equals 180, then we may conclude that ABCD is a cyclic quad. And the reason that we would use there is converse opposite angles of a cyclic quad. Okay, so the question could either say, if they give us this and this is a cyclic quad, then they could say determine the size of angle B, then we just use opposite angles. Or they would say show that ABCD is a cyclic quad, or prove, or whatever, with reasons. Then we would take the information that they gave us, we would show that the opposite angles are equal, and then conclude, therefore, ABCD is a cyclic quad. Next up, we're looking at exterior angles. So if you look at this shape here, we'll see A, B, C, and D all lie on the circumference. So ABCD is a cyclic quadrilateral. Then we are going to look at what they've given us here. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Okay, so an exterior angle needs to be formed by sides of the actual quadrilateral. So there, BC, and if you see CD is actually extended. So there we have an exterior angle. It can't just be any old angle. They might have another line here, or whatever with an angle. We can't just use this to say it's exterior to that. It's on the outside, but it's not considered an exterior angle. Okay, so the exterior angle is equal to the interior opposite angle. All right, so if they ask me for the value of angle A or the size of angle A, I could say angle A is equal to angle, let's call this C1 and C2. So it's equal to angle C2, exterior angle of a cyclic quad. And so therefore, angle A is equal to 100 degrees. Okay, and then, I'm sure you were waiting for it, the converse. If we didn't know that this was on a circle, okay, but they had told us that angle C2 and angle A were each equal to 100, then we would have a look at things a little bit differently. Okay, if angle A is 100 and angle C2 is 100, then we can say A equals C2. That would have been given to us if they gave us all that information. And so therefore, ABCD is a cyclic quad. Cyclic quad. And the reason there is converse exterior angle of cyclic quad. Okay, so once again, the first type of question, they just ask us to determine the size of an angle if we are given the fact that it's a cyclic quad. The second is that we'd be given some information and we'd have to prove that it's a cyclic quad by using that information and then the converse reason there. Okay, so here's one that we've looked at in one of our previous videos. Remember I said whenever we see a little bit of a bow tie shape, then we need to start looking for what is known as angles in the same segment. So C and D are equal to each other. That's now given. Okay. Angles subtended by a chord of a circle on the same side of the chord are equal. Okay, so that's the theorem there for angles in the same segment. But if that happens, we can deduce that all 4 points here are on the circumference of a circle. So all of these I've drawn with dotted lines now. Okay. So if that's true, so if we are given the fact that angle D equals angle C equals X, then we can conclude that that quadrilateral ABCD, and they might not have given you any of these dotted lines. So you must just be confident enough to know sometimes we're going to have to draw them in. Okay, but ABCD is a cyclic quad. Why? Because we've got here the converse of angles in the same segment. All right, and so that means that we may conclude that there's a circle touching all 4 corners of this quadrilateral and that there are these 2 chords, DC and AB. They also exist. Okay, so this is a continuation of the angles in the same segment theorem, but we're just looking at the converse here to say this is a way that we can prove a cyclic quadrilateral. Okay, let's practice a couple of examples to check our knowledge. Consider the sketch below and determine, with reasons, the size of F. There's F. Okay, so what am I seeing in this sketch? I'm seeing a circle and a whole load of chords, and then this one is going, it's being extended, but it's not a tangent. They didn't specify, plus a tangent wouldn't intersect my circle. It would literally just skim the outside. Okay, the other thing I like to look for is where are these points? So if I look at BCDG, do you see that all of those corners are on the circumference of the first circle? So that's a cyclic quad. And then GFED is also a cyclic quadrilateral in the second circle. Okay, and I've got a whole load of theorems about cyclic quads, so I'm feeling fairly confident now. Okay, they want this angle F. I don't know anything yet. So let's take the information that I know here and start to build a bit of a bridge. Okay, what I know is a couple of things. I'm looking for angles in the same segment, but then I would have a bow tie shape, so that's not true. I know that opposite angles of a cyclic quad, so that one and that one, that one and that one, those must add up to 180. And then I also know the one which I suppose is the most obvious here is we've got an exterior angle, right? That angle is outside of the quad, not inside. And an exterior angle is equal to the interior opposite angle. So it's safe to say then we could go inside here and then opposite to angle D1. So that would be my starting point, as I would say. Angle D1 is equal to angle B1 is equal to 88 degrees. And the reason there is exterior angle of a cyclic quad. So there we've got, 88 degrees there. Okay, now what do we notice? If we want angle F here, that's inside, and this angle now that I've just worked out, technically could form an exterior angle again. Do you see that? So it's outside of the yellow cyclic quad. All right, and that means it's equal to the interior opposite angle. So there we are, without too much difficulty, we have actually solved it. So angle D1 is equal to angle F, which is also equal to 88 degrees. And again, it's because of the exterior angle of a cyclic quad. Okay, so important to know your theorems so that you can straight away apply them. You see, I almost have a checklist. I'm like, these are the things I know about cyclic quads. Is it option A? Is it option B? Is it option C? And then I can solve. Okay, here's another example. Consider the sketch below and determine with reasons the value of x. Okay, so let's quickly see. 3x plus 10, 2x plus 20. That's where x is. It's like part of an angle. Okay, the other thing that is indicated here in the sketch with these two little lines is that A1 is equal to C. Okay, now everything we've been dealing with up until now has had a circle in it, and suddenly we're looking at what seems to be a trapezium almost with a little bit of an extension here. Okay, but that's not a problem. We need to just think about our grade 11 theorems and what we know. Okay, so I've got a quadrilateral. Okay, four-sided, four-cornered shape. And another bit of information which is helpful is that this exterior angle is equal to this interior opposite angle. Do you see that? Okay, so when I've just got a quadrilateral, I might be tempted to say, well, this plus this plus this plus this must equal 360. Entirely true. But I have too much information missing to make that work. Okay. Then I might be tempted to say, oh, well, this plus this must equal 180. But I can't just assume that. I need to actually prove it. That's only true in cyclic quadrilaterals. In other words, if there is a circle here, let's try and draw a circle around these points, then those opposite angles must add up to 180. And so that means my job is first of all to prove that this is a cyclic quad, so that I can use the fact that those add up. All right, how do I do that? Well, I can say I've got an exterior angle equal to an interior angle. So let's start out by saying that. Okay, so angle A1 is equal to angle C, and that is given. Therefore, ABCD is a cyclic quad. Okay, and the reason? Converse exterior angle of cyclic quad. Okay, and so that means this yellow circle now, or let's pretend it's a circle, is a true thing. And so now I can solve. I can say, well, therefore, this plus this must add up to 180. Suddenly the whole world is open up to me, okay, because I have a cyclic quad. So angle B plus angle D is equal to 180. Opposite angles of a cyclic quad. Okay, let's substitute in 3x plus 10 plus 2x plus 20 must equal 180. So we end up with 5x plus 30 equals 180. Let's take that 30 over. 5x equals 150. we can divide by 5. What I do to one side, I do to the other side. So x is equal to 30 degrees. I have solved the question there. Okay, so the biggest advice I can give to you is that we can't just assume that something is a cyclic quad. No. We have to first of all prove it. If we can't see the circle, we need to then prove that it is a cyclic quad, and then we may apply other versions of the theorem. All right, and then the other version we needed, or the other little bit of information that we could use, was the fact that opposite angles are supplementary.